Okay, these are the Algebra 1 6.3 notes. So what we're going over today is exponential functions. So on this one, we are graphing y equals ab to the x. This graph is when b is positive, and then this graph right here, the blue graph, shows when a is greater than 0, so a is positive. So when a is positive and b is positive, then the graph is going to look something like that, roughly. Now, when A is negative and B is positive, then you're going to have a graph that looks something like this. Now over here, the blue graph shows when A is positive and when B is between 0 and 1. So less than 1 but greater than 0, okay? And when that happens, your graph looks something like this. And this shows when A is negative and B is between 0 and 1. And your graph is going to be approaching the x-axis from beneath like that. Alright, so in your student journal on page 181, this shows these 4 questions, and on all of them it says, determine if the table represents a linear or an exponential function, and it wants you to explain why. So on this, first look at the change. Each of these are increasing by 1. So from 1 to 2 to 2 to 3 to 3 to 4, they are all going up by 1. Now look at the change of the y value. So for the y value, to get from 8 to 4, you are going to be basically multiplying times 1/2. To get from 4 to 2, you're multiplying times 1/2, and 2 to 1, you're multiplying times 1/2. So in this case, this shows an exponential function, and your explanation is going to be that as x increases by 1, y is multiplied times 1/2. So it's multiplied by a constant value. So we're going to say as x increases by 1, and then you're going to say y is multiplied by 1/2. Now let's look at number 2. On number 2, we look at this, and this, once again, x is going up by 1. So every single one of these, x is going up by 1. Now, if we look at this one, there's not anything we can multiply to get here, but we can say that y is adding 4 each time. So it is adding 4. And so on this one, this is a linear function. Because the change is constant, it's going up by 4 every time. Here, it's going down by 4, down by 2, down by 1, so the change is not constant. Okay, so we'd say linear, and our explanation would be because the change is constant. All right, so on number 3, we look at our change once again. So each of these are going up by 1 on the x value. And so on the y value, this one is going down by 3 on each one. So it's not dividing, it's just subtracting 3. So once again, this one is also going to be linear because the change is constant. Every single time the values go down by 3. All right, on number 4, we look at this one, and it's going up by 1 every single time. Now we look at this change. This change is a little bit harder to see because if we look at it from 0.125 to 0.5, it's basically being multiplied times 4. And how I found that, because I wasn't sure at first, was I took 0.5 divided by 0.125. And that is how I got a change of 4. So it's multiplying times 4 to get to 0.5. So now, once again, if you took 2 divided by 0.5, you get 4. So it's being multiplied times 4. Here, it's also being multiplied times 4. So if you think about how much it's adding, on the first one, to get from 0.125 to 0.5, it's adding 0.375. This is adding 1.5, and this is adding 6. So it doesn't have a constant change in the sense that it's adding or subtracting the same amount. It has a difference where it's multiplied by the same amount. So this one we'd say would be exponential. And we'd say that as x increases by 1, y is multiplied by 4. Now if you graph these, the exponentials would graph and they'd make a curve, and the linears would graph and the dots would make a line, and that's another way to tell. But we want to know how to tell algebraically with the numbers. We also want to know how to tell by graphing the ordered pairs and seeing what the graph looks like. Alright, so looking at numbers 5 through 7, on page 181 in your student journal, it says evaluate the function. This is pretty easy. We're plugging in x, and so we're doing 3 to the 5th power because x is 5. So we plug that in right there where it says x. Now you can just go and type this in your calculator to find out what it is, and you do 3 to the 5th, and we get 243. So we would say, okay, y equals 243 when x equals 5. Here we do the same thing. We're going to have 1/4, and we're going to plug in 3 because x is 3. So once again, we go over to our calculator. Now I'm going to put 1/4 in parentheses, so 1 divided by 4. Then I'm going to use the caret button to the 3rd power. I hit enter, and I can go ahead and do math fraction to see what that comes out as a fraction. And it comes out to be 1/64. Now if you're trying to do this on your iPhone and you're thinking about how you could get it as a fraction, you could do 1 to the 3rd power over 4 to the 3rd power. 1 to the 3rd in your calculator is 1, 4 to the 3rd is 64. So that's a way you could come up with this answer if you were not using like a Texas Instruments or a scientific calculator at all. So on this one, once again, we're going to plug in x is 4. So now look at how I type this. I'm going to go in and I'll do 3 times, and I can do parentheses or I don't have to really, I can do 4 to the 4th. Now if in doubt, if you're just worried about it, go ahead and plug it in exactly like it shows it on the problem, just to make sure 100% that you are getting the correct answer. And so we get y equals 768. All right, this one says to graph the function. It says compare the graph to the graph of the parent function and describe the domain and the range. So first of all, let me just show you the parent function. So when it says a parent function, the parent function of an exponential function is 2 to the x, or it can sometimes be 1/2 to the x. And we'll talk more about this in class, but just to get you started. So if we want to show what the graph is for 2 to the x, we can go in and we can just look on a graphing calculator and do 2 to the x, and let's go ahead and graph it. You could also go ahead and show this on desmos.com if you'd like. Now, if you were to zoom in, hopefully what you'd see is that it's going to have the y-intercept go through at, and if you're not sure how, you can just go ahead and zoom. And you can do a zoom box, and that is where you scoot over and you basically draw a box in around the part of the graph you'd like to zoom in on. You could also look at your table to get some values to really see what it is, but it's definitely worth your time to go ahead and kind of try to get a closer look. So I am drawing a box around the portion of the graph I would like to see closer. So it's starting to form a box, and when I get it where I want it, I'm just going to hit enter, and it's going to zoom in exactly on what I selected. So if we go ahead, went a little too far there, guys. So if we go ahead and hit enter on this, it's going to zoom on that part. I might scoot it back just a little bit and hit enter. So if we look at this, notice it goes through 1. And so this is going to have a y-intercept of 1. Now it doesn't cross the x-axis. If we wanted another point from it, we could kind of look at this and think that at the point x is 1, it's going to be at 2. And at the point x is 2, it's going to be at 4. So there's some very specific points, and from there you can just kind of draw your curve in. So that's what's called the parent function. That's y equals 2 to the x. All right, if we look at this one, if we go ahead and just go on a graphing calculator or go on Desmos and graph it just like that, don't use parentheses because they did not. So we're going to do -2 to the x. If we look at what happens to this, and it's graphing under the same window, which is fine. Notice now what happens, and I'm going to go ahead and graph this on our graph paper. So what happens now is it has an intercept at -1, and then if you look up its points, you can either look on the graph or you can go and do second graph. It pulls up your table. So it's going to have a point at 1, -2, and at 2, -4. Now if you think about that, that's very similar to points we had here, except the graph is now down below the x-axis. So if I wanted to explain this, if I wanted to be really specific, I could say that the graph is a reflection of the parent function, and it's a reflection over this axis, so it's over the x-axis. All right, and then I could also, to compare it, I could say the y-intercept of the parent function is at 1. and the y-intercept of f of x is at -1. Now, if I wanted to know the domain and the range of f, that's of this function up here. So the domain, keep in mind, that's the x. How far does it go? It goes left forever, and it's going to go to the right forever. So the domain is going to be all real numbers, or if we want to do that in set notation, we could say it's going to go from -infinity to +infinity. The range, if you look at this one, it's never going to cross the x-axis. So it's going to be every y value less than 0. And we don't say less than or equal to because it will not ever touch it. So if we wanted to say that in set notation, we could say it's going to go from -infinity to 0. And we use parentheses because it will never actually touch 0. So now on this one, let's go ahead and take a look at this. Let's look at the parent function first. So if we look at this and we go to y equals, and we go ahead and we do 1/2 to the x. All right, so if we graph this and take a look at it, I'm going to go ahead and leave my window where it is because it gives us a pretty decent look. So if we were to look at this, let's go ahead and just graph them both on the same axes this time. So I'm going to do the parent function in black. So it goes through at 1, all right? And then we can look at our graph, and we could pull up our table if it helps us, and we could say that there is a point at -1, 2, and -2, 4. And then at 1, it's at 1/2. And at 2, it's at 1/4, and so on. And it's going to get closer and closer and closer to the x-axis, but it's never actually going to touch it or cross it. If you scroll down your table, you'll see these numbers get smaller and smaller and smaller and closer to 0, but they will never be exactly 0. So now, that's our parent function. That's y equals 1/2 x. Notice that it's curving down, where this one curved up. So if we want to go ahead and we want to take a look at our function 2 times 1/4 close parentheses to the x, and then we graph it, we can get a view of what the graph's going to look like. This is still decreasing. Sorry about that. This is still decreasing because it's coming down. The number in here is 1/4, so since it's between 0 and 1, it's going to be a graph that is decreasing. Now, if we look at this, once again, we can pull up a table, and I'm going to go ahead and switch colors and see. We have -1, 8. Now, -1, 8 is not going to quite fit on my graph. 1, 2, 3, 4, 5. But if we go ahead and estimate it up here somewhere, 0 is at 2. 1 is at 1/2, so that point's the same. 2 is at 0.125, so getting super low. So this one is going to drop really fast, very steeply, but still approach 0. So now on this one, if we want to go ahead and if we want to compare this, then we look at the graphs. They're both going down. We want to get very specific. We can say that the graph of f of x is a vertical stretch by a factor of 2. We could also say that the y-intercept of the parent function is 1, and the y-intercept of f of x is 2. Now for the domain and the range. The domain on this one, once again, it's going to be all real numbers. It's going forever to the left and forever to the right. It will go on continuously. If we want to do that in set notation, we could say it goes from -infinity to +infinity. Now the range goes up forever, but it only gets closer and closer to 0. It never touches it, and it never crosses it. So the range is going to be y is greater than 0, or we can use this notation. We can say it's going to go from 0 to infinity. Once again, using the parentheses because it's not actually going to touch 0. All right, on these, they want us to graph a function and describe the domain and the range. So on this, if we just go into either Desmos or a graphing calculator, it can help us pull up some numbers. If we didn't have a graphing calculator, one way we could do it is just make a table with values. So we could take a look at -1, 0, 1, 2, and 3. That would not be a bad way to do it if you don't have access to Desmos or a graphing calculator. So you would plug this in for x and find out what your y is or what your f of x is. So if we want to go ahead and just use our calculator, we're going to do 4 to the x, then we're going to do -2. Now, we can pull up our table or we can pull up our graph. I'm going to go ahead and pull up our table. So at -1, it's -1.75. At 0, it's -1, 1 it's 2, 2 is 14, and 3 is 62. Now, I'm probably not going to go ahead and graph all the way up to 62 just because that would make us have a really big scale on our y-axis. But I do think I'm going to go ahead and I'm going to try to get up at least close to the 14. So if I go by 2's here, 2, 4, 6, 8, 10, 12, 14. Okay, so I'm going by 2's. Here on the x-axis, I'm going to go ahead and go by 1's. So I want to mark my axis to make sure that we know what we're going by. So -1, -1.75. This to be -1, -1.75. Keep in mind that's going by 2's, be right there. 0, -1 will be right here. Over 1 up 2 would be there. And then 2, 14 would be all the way up here. So that's going to be a very sharp graph. So it wants us to describe the domain and the range. Once again, the domain is going to be all real numbers or from -infinity to +infinity. The range, this one's a little harder, so let's look back here. Let's look at our table. So if you notice, it's getting closer and closer to -2. Now it's going to say it gets exactly to -2 because the calculator rounds it. Let's take a look at the graph and see what the graph looks like. Now I'm going to go ahead and I'm going to go zoom standard, which just puts it back at -2 positive, from -10 to +10 on both axes. And I'm going to trace it. Now if you trace it, take a look at my y value. It's getting smaller and smaller, this one right here. It's getting closer and closer to -2. Now, although the calculator may have to round it to -2 at some point, it's not actually going to touch -2. So this line right here at -2, it will never actually cross or touch. It's called an asymptote. So the range right here is going to say that it's going to be from -2 and up. So we could say y is greater than -2, or we could say from -2 to +infinity, but it will never touch it, which is why we don't do greater than or equal to. So over here, let's take a look at this one. Once again, we could do our table like this, or we can use a graphing device to figure out what it might be. So we can do 4 times 1/2, and I'm just going to go ahead and do 0.5 instead of 1/2. And to the, now I'm going to put this in parentheses because there is x plus 1. So let's take a look at this, and let's go ahead and look at the table real quick, see if we can get some points to put on. Now obviously -14 would not be a good plan because of how big those numbers are. So let's take a look right here. Alright, so the numbers seem fairly normal and easy to deal with. Back, I'd say maybe until -3. So let's just start at -3, it's at 16, -2 is 8, -1 is 4, and I'm sure right now you can see the pattern here. So we're going to go to 0, which is 2, 1, which is 1. And let's go ahead and do 2, which is 1/2 or 0.5. So these are our x values over here, and these are our f of x values or our y values. So let's see if we can graph this. Here's what our graph is going to look on a standard axis. So that shows me that it would probably be okay if we didn't really show too much of our negative area. So I'm going to want to go by 1's down here, so I'm going to mark that. And up here, I think I'm still going to go by 2's because 2, 4, 6, 8, 10, 12, 14, 16. It gets me up to 16, which is awesome. So if I graph these points, -3, 16 is right there. -2, 8, 2, 4, 6, 8 is right there. -1, 4, 0, 2, 1, 1, and 2, 1/2. So you see our curve right there. Now our domain, once again, goes forever to the left and the right. So our domain is going to be all real numbers or from -infinity to +infinity. our range, it is coming closer and closer to 0. Let's just go ahead and take a look at our values and see if it ever does touch 0 where it's y. So I'm going to do second, and I'm going to do graph, and that pulls up my table. Now if you see, they're getting smaller and smaller. This is in scientific notations. This is the equivalent of saying 0.00098. So they're just getting completely smaller, never touching 0. So the range is going to be y is greater than 0, or from 0 to infinity. But once again, this is where our asymptote is. It never touches or crosses this line. Alright, so over here it says, write an exponential function represented by the table or the graph. Alright, so if we want to do this, there's several different ways we can kind of start to approach it. I personally would say we start with our standard form. So our standard form, if you remember back on an earlier page, was a times b to the x, okay? Now, let's go ahead and let's take a quick look at that page. I'm going to go back and show you. So we're referring back to our notes right where we started our video. So if you look at this, notice that a is always the y-intercept. So right there, if we know the point that's 0, comma, a number, then we know a. So let's take a look at this example and let's see what we know. So right here, we know 0, 3. So our a is right here. A is 3. Now, I want to find b. So what I'm going to do is I'm going to pick another point, and I'm going to plug it in for x and for y. So I'm going to plug in 1 for x and 18 for y, and I'm going to try to solve. So what I can do, I have b to the 1, which is the same as just b. So now I can divide by 3 on both sides, and I find out that b equals 6. So if I rewrite my equation, I have y equals 3 times 6 to the x, and that's my equation. So right here, once again, I know that this number is a. So I pick a point, any point at all. I'm just going to go ahead and choose this for x and this for y. And if I plug this in, I have y equals a times b to the x. So now I'm going to plug in y as -1, a as -1/2 or -0.5, b I don't know yet, and x is -0.5. So now the first thing I can do is I can go ahead and divide this side by -0.5, and I can divide this side by -0.5. So once again, you could go and you could type in a calculator if you need to, and you could divide them, and you find out that 2 equals b to the -0.5. Alright, so if I think about this, I know that when it's a negative number, it's the same as being on the bottom. I also know that if I want to get rid of this, one thing I could do is take it to the 1 over whatever that is. And that's like doing a root, and they're going to cancel each other out, because when it's a power to a power, we multiply them, these would multiply to 1. But if I do it to one side, I have to do it to the other. Now this gets a little tricky to plug in, so let me just show you how on a calculator. So if we go back in, we can do 2 to the, and then we can do the 1 divided by -0.5 power. We put it in parentheses, and we find out that b equals 0.25 or 1/4. So our equation is y equals a was -0.5, b was 1/4 to the x, and that's our answer. Alright, this one says to graph the function 2 to the x, and then to graph this function 2 to the x plus 3. So I'm going to go ahead and do this one in red. So if we start here, once again, if you don't remember how, you can go in here and you can do 2 to the x. This is our parent function. We can either pull up the graph or we can pull up the table. So I'm going to go ahead and pull up the table. So we know that our basic numbers, because there is nothing in front of here, it's like saying 1 times 2 to the x, so the y-intercept is going to be 1. So I'm going to go ahead, just give myself a little bit of room because we don't know for sure what the other one's going to look like. And I am going to graph this as 0, 1, so I'm going by ones here. -1 is 1/2, 1 is 2, 2 is 4. So I'm going to call that good. That's going to be my function f of x. Now on this one, I'm going to go ahead and I am going to do 2 to the x plus 3. And so if I go and I graph it, I'm going to have 2 to the x, and then I'm going to do plus 3. All right, if we take a look at that on the table, what it looks like here is we have at -3, it's at 3.125, so roughly there. At -2, it's at 3.25. -1, it's at 3.5. 0, 4, 1, 5. 2 is going to be at 7. So that looks like it's going to curve and get closer and closer to this line at 3. This is y equals 3, and that's probably the asymptote. So it says, how is the y-intercept affected by the translation? The y-intercept is moved up 3. So y-intercept goes up 3. The domain is the same, so we're going to say domain, or we're going to say remains the same, because it's still from -infinity to positive infinity. Now the range, here the range on this red one is going to be, let's go ahead and write it in red, the range is going to be y is greater than 0, where the range on this function is going to be y is greater than 3. And so we say the range shifts up 3. All right. And we're going to go ahead and save this one for in class. So that is the end of your notes. Be sure to write down any questions you have and bring them for me so that we can go over them in class. Thank you, and sorry about the interruptions.